Hello, hi, good morning my dear students. Welcome to the chemistry class. So in the last class we have discussed about the colligative property. That colligative property can be discussed on the basis of four concepts. That is relative lowering vapor pressure, elevation boiling point, depression freezing point, and last one is the osmotic pressure. I said you the final equation, that is mb is equal to, based on those four terms, that is the final expression is the most important. Along with that you have to remember the terms, what mb means, what wa, wb and kb, kf, delta tb, delta tf. You have to remember that all things. Pi, particularly in this chapter, pi is not referred as a 22/7. Pi is nothing but it is a osmotic pressure. I hope you know this one. So I just remind you, please keep in your mind that formula should be thorough. And I already sent the notes for those who have already sent the notes of the previous chapter. For them it will be easy. For those who are incomplete in their notes, they feel difficult, that's all. So here last very single concept is left, that is nothing but in the solution chapter, association of solid molecule, dissociation of solid molecule. So here association is nothing but what? Association of solid molecules are nothing but if the solid particles are undergo association at that condition, what happens means the number of solid particles are going to decrease in the solution. If the number of solid particles are going to decrease in the solution particle, at that time the colligative properties decreases. Keep in your mind, as the number of particles of solute increases, colligative property increases. In association of solid molecules, the solute particles are decreases, for that reason colligative property increases. And reverse of that one is dissociation of solid particles. Here what happens, the number of solute particles are increases, for that reason colligative properties are increases when the solutes are undergo dissociation. I hope this is not much important for you. Why? Because in this year it is already reduced. So why? Because it is continuation of next one also. For that reason I don't feel that they are going to ask. They never are asked in the previous years also. Only for your understanding you should know, association it undergo the colligative property decreases, in the dissociation the colligative property increases. And one more thing, the next one, that is Venta factor, the next of this concept. Actually it is reduced, it's not there, and it not takes more than 1 minute to explain. And for competitive exams this is most important, and it will be asked for 1 marks in if it was there in the annual exam, but it is reduced. Don't worry, I will explain you, just I need 30 seconds. Okay, that is Venta factor. So here, what is Venta factor? It was asked in the previous chapters, previous years actually. So Venta factors is represented by the symbol I, small letter I, whereas Venta factor is defined as the ratio of normal molecular mass divided by observed molecular mass. In the notes you can also observe that the observed colligative property, here I have written observed colligative property divided by calculated colligative property. You may define the Venta factor on the basis of either this formula or by using the colligative property. Both are same. But moreover, what you have to remember is the Venta factors we are defining on these terms actually. What is the Venta factor of? What is the Venta factor of? They are going to be some of the molecules. That is, what is the Venta factor in the sodium chloride? They may give you. Here Venta factor means you have to say the number of ions in the compound. In NaCl there is a 2 ions. Sodium having Na plus ion 1, chlorine is having another ion. Look here, number of cation is 1, number of anion is again 1. Therefore total number of ions are 2. Therefore sodium chloride is having the Venta factor is 2, whereas aluminium chloride, in the aluminium chloride, what is the Venta factor? Just split the ions. Aluminium, which is having charge +3, chlorine is having charge -1. but number of chlorine atoms are 3 here. Can you see here? 3. Therefore, I am going to write 3. Look here, the total number of ions, aluminium, cation is 1 and chlorine is 3. Therefore, totally 3 plus 1. Total number of ions are 4. Are you getting my point? Aluminium is 1 ion, chlorine is totally 3. Therefore, total number of ions are 4. 4 is the vector factor for aluminum chloride. 2 is the vector factor for sodium chloride. This is how they are going to ask in the annual exam. But right now in this year you are not having this in the syllabus. But you have to, apart from this definition, you should remember how to calculate the vector factor of given compound. Are you getting my point? So this is about the vector factor, and this is the very last concept of this solution chapter. And finally we left and we are at the end, that is the problem on calculating the MP, that is molar mass of solute. B matlab solute, A is nothing but solvent. You should know this one. So look here, in the notes I have given soon after finishing this vector factor, I have given one problem, that is vapor pressure, based on vapor pressure. I hope I already solved that kind of the problems, so that's why I don't want to continue that one. Whereas in that problem one mistake is there, so I request you, very 1 or 2 students have already written and submitted the notes. Please don't do like that. For because of that reason I am not sending the notes in the early. What happens means, without understanding how can you write, this is wrong expression, wrong method it is actually. Unless and until you understand the concept, you are not supposed to write that one. If you write means no use also. Without understanding, without knowing the concept, only for the sake of me, to show me as a you have completed the notes, you are writing. So that is bad habit. Please don't do that one. Okay. And those who have already written plus, so please make some correction there. So in that there is a one step is there, 17.53 minus PA, 17.53 minus PA naught divided by 17.53. Some values are there. In that some values are there. But I have written this one by sending this. I have written in the denominator. Actually, it is going to come in the numerator. Here it has to come. So when the 17.53 comes here, it has to come to the right side, up it has to come. So it means that everything remaining should be same. So don't simply copyright the problems, understand the concept and try to write the given data by understanding yourself, and try to solve that individually by your own calculator. Solve that one and cross check whether the answers are same or not. Are you getting my point? And the final answer, that is PA of this one, is almost same. It is in the book of 17.53. You may get 17.43 or 53. Sometime it may be a 6 also. 17 point answer, final answer is same, but calculation and everything is wrong. From here it is, just cross check that one and do it once again. Okay. So coming to the next one, that is, I say you, these all problems are important. Calculating the molecular mass of solute using relative vapor pressure, osmotic pressure, elevation boiling point and freezing point. So let's begin that one. So as I said you have to remember that problem without fail. Okay. Here we are solving the problems based on the molecular mass of solute. Okay. So I said you have to remember the 4 formula. In that, among that one, the second one, that is the calculation of molecular mass of the solute using the depression freezing point. I said you F is nothing but freezing point, B is nothing but solvation of boiling point, pi is nothing but pressure, osmotic pressure. Look here, so I have given some of the given data, so you can just go through the notes. Here the problem is 1.4 gram of the acetone dissolved in 100 gram of benzene. 1.4 gram of acetone. Acetone is dissolved in the benzene. So acetone is nothing but solute, that is nothing but B, and benzene, 100 gram of benzene. Benzene is nothing but here A, because it is a solvent. Give a solution which freezes at 277.12 Kelvin. Means these solutions are freezing at this temperature, and pure benzene is freezes at 278.4. means pure benzene freezing point they have given. Pure is nothing but not we are calling that as delta TF naught. TF naught is nothing but here benzene, that is 278.4. Here I have written not indicates the pure solvent and without zero, that is TF indicates the freezing point of the solution. It is together solute and solvent. So next one, if to this solution 2.8 gram of the solute dissolved in 100 gram of benzene, means the solvent is remain same 100 gram of benzene only. In this 2.8 gram of solute, which solute we don't know, they have not given, but they have given only solute mass. They have given the given mass of solute and it is dissolved in 100 gram of benzene, give a solution which froze at 277.76. 277.76. Look here, freezing point of the solution they have given, that is 277.76. Initially it is 1 2. Here initially the freezing point of the solution was 277.12. It is 277.12. This is 1 2. Here what you have to do is they have given you to calculate the molecular weight of the solute. So which solute they have given we don't know, because initially in the first condition they have given the solute as the acetone, but you are not supposed to call the mass of the acetone because acetone is added to the benzene only. Other condition freezing point of the benzene and solution they have given, the difference we are calling that as delta TF. Delta TF, that is we are going to get, and they have given the mass of the benzene, that is solvent is 100, and mass of the acetone, that is solute 1.4. Using this one, and they also given that molar mass of the acetone, it is understood molar mass of the acetone is taken as 58. It's not that complex, it's 58. 58 gram is nothing but it is the mass of the acetone. We know the formula of acetone, CH3COCH3. Therefore by knowing the formula we can able to calculate the molar mass of the solute, that is acetone. And using this concept, what we have to calculate is, first we have to calculate the constant, freezing constant, right? That is Kf. They have not mentioned the Kf value. For that reason, using this previous data, we have to calculate the Kf. But we know that MB formula, we know MB is equal to WB into 1000 into Kf whole divided by delta Kf into WA. Here they have given every for data MB, WB, delta TF, we know this one, and WA also they have given mass of the solvent. From using this data, first we have to calculate the freezing constant. Using this freezing constant, again we have to calculate the mass of the solute, unknown solute. That's why they have given, that is WA they have given. WB, that is 2.8. This 1.4 is a mass of acetone, and molar mass of acetone we can calculate it, that is 58. Using the formula, carbon is having the atomic mass and oxygen mass. Based on that we can able to calculate the mass of the solute, that is 58, but we don't know the which solute it is. Simply they have given the unknown solute, that is 2.8 gram of any another unknown solute is dissolved in the same quantity, means same of the solvent, that is benzene, of same gram, 100 gram only. Can you see here the 2.8 gram of the unknown solute again dissolved in the 100 gram of the solvent. In this condition, the freezing point of the pure benzene remains same. Can you see here delta TF naught is having the same value 278.4, whereas frozen point of the solution is 277.76. Here again you have to calculate the delta TF. Delta TF is slightly varies from here to there. Why? Because the freezing temperatures are different here. For that reason, delta TF you have to calculate using these two conditions. That is delta TF can be calculated by the formula delta TF naught minus delta TF. We just calculate the 2, that is delta TF, and using this delta TF you can calculate the MB. MB's formula is here. Here MB you have to calculate. What about WB? They have given, that is 2.8 thousand into Kf you have already calculated using this all data, that is Kf is 5.3. Delta Tm you can calculate by difference of these two, and Wa is nothing but it is given 100 gram. Using this all given data, you can able to calculate the molecular mass of unknown solute, that is 2.8 gram of the solute. Therefore, the final answer is 231.87. But in the notes, I have not mentioned you the second problem calculation, means calculation of MB. Simply I have written the formula. Why? Because you have to solve that one. Okay, so this is the first problem. I hope these are not the much difficulties comparing in the previous vapor pressure. It is having some criteria, you can't even understand the given data also. Here there is no such problems are arising. It is very easiest concept. Only the thing is you have to remember the formula. If you are thorough about the formula, you can able to write the given data also. So this is about the first one, and we will move the second one. In the second problem, it is almost same, so I would like to give you as a homework. So check it out. Don't copyright the problems. First you understand the given data, and here given data I have mentioned, but don't see that one. Just you read the problems and write by your own self. Write the given data and calculate by your own somewhere in the rough, and try to compare the answers. Don't worry about sometime whichever I have given the answers, that may be wrong. That may be wrong. So that's why, for that reason, do yourself and get the answer and cross check whether it is correct or not. Okay, so this is about the freezing point, first one, and second one are the second and third. In the third one also I did some half, so it means that the difference division you have to do that one. So do the calculations yourself and tell me the final answer of that third one. Okay, in the third problem, that is in the beginning of, that is addition of 0.643 of the compound solid, it is added. So in this third problem, I have given every given data and problem also, whereas the final answer I kept it as a question mark, but you have to solve that one. So I have given the given data also, and to the equation I have substituted the data everything, but in between I kept as a backend. Just you have to solve that one, use the calculator, and you have to bring the answer. The final answer is 156.056 gram per mole. So this is about the calculation of molecular mass of solute using the F, that is freezing point. Whereas in the last one, that is calculation of molecular mass using the osmotic pressure, that is pi is nothing but osmotic pressure. Using the osmotic pressure, we can able to calculate the molecular mass. So I hope you can think that. So we have already solved only two kind of the problems, whereas last, in between first and middle one, is we have kept backend. We are not solving that one. Why? Because it is not there in the syllabus. No doubt the problems will be there based on the formula only, but such kind of problems are not present in your textbook, or it is not solved. It means it is understood that in the examination point you are going to get only this kind of the problems. Okay, so for that reason, just focus on these two kind of the problems. And also here, while calculating the molecular mass of the solid, R is nothing but gas constant. In gas constant, in the previous we have observed that the gas constant is 8.312, whereas here we are knowing that the gas constant, we are using the formula, that is 0.0821. You have to use this as a gas constant. So in this gas constant you have to use this one, and where substituting the volume of the liter, any of the compounds in the liquid compound, we have to take some of the given data. They have given the volume in milliliter or dm cube in the form. So you have to convert that in the form of liters. If they have given 500 milliliter, you have to write that as a half liter, 0.5 liter. So volume should be in always liter, not in the milliliter, and gas constant, that is should be in the form of 0.0821. Don't write any other gas constant values.